Okay, so we need to have a look at graphing the transformations of exponential functions. So there's a few questions for you to try. So you need to create a table of values, graph the functions, and state the domain and the range. So create a table of values. Now we need values for x and y. So we're going to use -3, -2, -1, 0, 1, 2, and 3. And we're going to just substitute in, instead of x, our values here to calculate y. So 2 to the power of -3 plus 3 minus 5. So, and then we will have our new y value to plot. Okay, so -3 plus 3 is 0. 2 to the power of 0 is anything would be just 1. 1 minus 5. Now, if we're not sure, we can use a calculator. So if you use a calculator, so if you don't have the class whiz, you can go onto this button here, which will be mode, and you can either find, if it's an old one, 3 or number 7, I think is tables. If you have the class whiz, you can go across and it's option 9. So press equals for that. So we can put in our f of x. So we're going to put in 2 to the power, and it's minus, and we're going to put, not minus, sorry, we're going to put in alpha and x. And then it's plus 3. And then arrow across minus 5. Okay, so g of x, we'll put it as 1. Okay, so our table of values is starting at, so you've got -3 up to 3, so I'm going to put -3. And we have a step of 1, and we're going to end it at 3. Okay, so this is going to give us a table of values. So you can see here, if it's -3, the answer is going to be -4. So this is going to be -4. So if we had 2 to the -2 plus 3, so 2 to the power of 1 is 2. 2 minus 5 is going to give us -3. So we can complete that, or we can take the values on our calculator. So 1, we have 3. If I scroll down, it's going to give me the values. So I've got 0, 3, 1, 11. And 227, 227, and 359. So here's my values. So I'd be able to plot these. So then what I need to do is go to either some graphing paper. So I've come over to Desmos here, and here we have a graph. So if you plotted our table of values for this this graph, okay, we're going to have so there's our 0, 3, and we need to state the domain and the range. So let's have a look. So we can see our graph here. So our lowest point here, where our asymptote would be on the line y is equal to -5. Okay, we have our intercept here, which is at 0 and 3. So our domain for x, the x values, this is going to be the set of all real numbers. And our range, which is the y values. So this is going to be in the set, And our y values, because it's increasing, is going to be anything greater than -5. So y is greater than -5. So our second, we're going to do a table of values. So this time we have a tenth. So this is going to change our shape of our graph. And we're going to use -3, -2, -1, 0, 1, 2, and 3. And y is going to be 0.1 times 6, and then it's the power of -3, etc. So I'm just going to complete my table. And if I do this on my calculator, so we'll cancel this, so we'll have (0.1). So 0.1 multiplied by 6. And this is to the power of x. And then it's going to be -3. So again, we're going to start -3, 3, and step as 1. And we've got our values. So I'm just going to put those in my table. So if you plotted the point for our graph, we will have an intercept. So is at -3. So this is at -3. And so we need to work out the domain. So the domain, that doesn't change. So it's going to be all the real numbers. So this is, sorry, let's just wipe that out. And the range. So if we add an asymptote, the asymptote is here. So it's not going to quite reach 3. So we're looking at -2, 9, 9, etc. So it doesn't quite reach 3. So the range of values is going to be in the set that's greater than -3.